Well, hello everyone and welcome back to Adrian's Digital Basement. On today's video, we're going to be taking a deep dive repair into this, which is a Macintosh 128/512/Plus analog board. It's the power supply / CRT driver from one of those early classic Macintoshes, and this one was sent in by Tommy at Arctic Retro. He sent it in for a mail call episode a ways back. He said it didn't work at all, and it needed some troubleshooting. So that's what I'm going to do on today's video. One other interesting thing about this is it is an international version set for 220 or 240 volts. So I'll have to use a step-up transformer to do any kind of repair work on this thing. So without further ado, let's get right to it. Alrighty, so let's take a look at this board that Tommy sent in. I don't actually know what's wrong with this, and the only thing I do know for sure is that this is an international version that runs on 220 volts or 240 volts, so I'll have to use a step-up transformer to use this here in North America. Now, if you've worked on Macintoshes, you may find it odd that it's got this red battery holder, and I have to say, I've personally never seen that either, but looks pretty cool. Looks like right at the top here, it has international stamped on there. We can see that it's got a rather large Rifa cap right there, which I'll have to take out and change. And it also has this wire that's attached directly to the power switch, and it looks like to this inductor right here. Assuming this went to like an extra board that was inside the machine. A lot of times with those original Macs, if you had some type of an expansion card like plugged into the motherboard to add more CPU power or maybe an internal hard drive or something, it would actually have an entire separate power supply in the case, and you needed something like this to take off the mains and send it over to that separate power supply module. On the Mac 128/512 and Plus, this cable here actually takes all the power from this board, the DC power, sends it to the motherboard, and then the video signals and the audio come back through this connector back into this board to feed the CRT. And there are a couple extra connections on the board. There's this one right here. This goes to the CRT itself, to the little connector on the back of the CRT. Obviously, this is the high voltage anode connection, so that goes to the CRT as well. And this connector here goes to the deflection yoke on the CRT as well, and that's what moves the electron beam around so you can actually see a picture. Now, it does appear that this power supply is multi-voltage, and it says here for 120 volt operation, W12, which is a jumper link, must be in place, and if it's removed, the power supply runs in 240 volt mode. And right there is W12, and you can see it's removed, so this thing is configured for 240 volts. Now what I wanted to do is compare this international power supply to the North America version. So this one here is a North America version, and while it is similar, and I can't really get this fully in frame, it's definitely different. Looks like this upper section of the board here, which is for the CRT, looks basically the same. Not really noticing any actual difference. And then the power supply section, which is this lower half, is similar, but there are some differences, especially in this area right here. I was hoping that these two supplies would be identical. That way I could compare values on this one, which I think works compared to this one that has a fault. I know schematics exist for the North America version of the power supply, but I don't think any exist for the international ones. And a lack of schematics and component values can really hinder the repair process. So I could switch this power supply over to running 120 volt mode, but I'm going to leave it in 240 volt mode, and I'm going to use this, which is a step-up transformer. Actually started life as a step-down transformer, but I took it apart and reversed it inside, so rewired it basically, so it is now a step-up transformer. And this is the test setup I have. So we have Tommy's power supply here, I have a motherboard connected up, and I have the multimeter connected up to the 5-volt rail, so when I power this thing on, I'll be able to immediately see if 5 volts is okay. As I turn the camera here, we have a CRT connected. The deflection yoke does need to be connected for high voltage, so it is connected onto the board. I do not have the neck of the CRT, this connector here, connected, mainly because the cable is not long enough. But what I do have is the ground lead that is going to the motherboard. I have a couple clip leads going from the tabs on the CRT to this black wire, which was originally connected to the tabs on the CRT. you need to have this ground connected back to the PCB where the high voltage is generated. Because you have to remember that the CRT is like a large capacitor, and one of the legs is connected to this flyback transformer right here, this wire, and then the other part of it is connected to the outside of the CRT, which is the ground, back to the PCB. And just off the view of the camera, I have the step-up transformer. It is currently off, so I can safely turn the machine on like that, and let's see what happens. Okay, so we're getting 0.2 volts on the 5-volt rail to the motherboard. And there was some kind of a high voltage sound coming out of the power supply as well, sort of a little bit of a squeal that indicates that something is shorted on this board. Let's just try that one more time. Yep, 0.3 volts. Okay. Now the DC power supply, which is on this part of the board, generates the 12 volts and the 5 volts that goes to the motherboard, but it also generates a 12 volt signal that goes to the top part of the board, which powers up the CRT. All right, so the first step we need to do is start looking for shorted components on the power supply section of this board. I've gone ahead and I've unplugged the cord, not to mention the step-up transformer is off, just to make sure that nothing is energized here. Let's first talk about the switch mode power supply topology that this thing is probably using. Now, I'm just guessing by looking at this. I haven't looked at any schematics. The mains comes in here, goes through some filtering. This is like EFI type filtering. These 4 diodes here act as a bridge rectifier that convert the AC to DC. It goes through these capacitors here for smoothing. And then this heatsink right here, this tall one, is almost certainly going to be the chopper, what actually switches the DC at high frequency that then goes into this transformer and is converted into the lower voltages required for the 5 and the 12 volts. This little component right here, which looks like a transistor, is going to be the controller or whatever is actually doing the switching. It is what is telling this large transistor here to actually switch on and off. Once it goes through this transformer, the 2 rails are going to go through these diodes right here, which are going to convert the 5 and the 12 volts from an AC chopped signal back into DC, which then goes through these smoothing caps, which then turns it into the DC that goes to the motherboard and the CRT side of the board. There will be some kind of a feedback circuit on here, which I'm not immediately seeing where it is. And that will make its way back. It's probably this circuit right over here down this lower area. Maybe this is an optocoupler right there that connects the low side to the high side. That feedback circuit is allowing this to actually regulate the voltage, and there'll be a potentiometer, one of these on here, that actually adjusts that feedback voltage that goes to this side, which lets you to dial in the exact frequency of the 5 volts. And then, like I said before, the 12 volts is derived from the 5 volts. I mean, basically it's regulating the 5 volt supply, and the 12 volt supply just sort of goes along for the ride. Now, the interesting thing is, it sounds like it's attempting to run. The fact that it's kind of making a squealy sound implies that the switching side is actually working. And I bet you if we power this back up and I measure the voltage that is actually going into this transistor, that is the high voltage DC after these smoothing capacitors, it's probably fine. I wouldn't be surprised if the short is over on this side over here, or maybe on the CRT side of this board, that is keeping this entire thing from starting properly. With the PCB flipped over, I wanted to try to figure out exactly where I can measure the positive DC voltage that's going into the switcher, and it's going to be right here. These are the 4 capacitors that do the smoothing, and the 220 volt mode of this power supply means that it uses them in sort of a doubling configuration. So that leg right there is the positive, and that leg right there is the negative. Now we can see that the positive here comes out of this power supply and makes its way to this pin right here, which is on the transformer. And it also makes its way to this large pin right here, which is the metal tab of the switching transistor heatsink. It means that that heatsink is energized at mains voltage, well, higher than that because it's been rectified, while this thing is turned on. So definitely this thing is dangerous while it's powered on. Alrighty, so let's see what the voltage is on here right now. 240 something volts. So even while this thing is off, that could give you a big zap. So if we turn this on, nothing is connected right now, right? The motherboard or nothing. And we should be getting like 400 something. 335 volts there. Okay. So yeah, pretty big potential. And what about here? On one of the caps, 132, but yeah, across both of these, this could give you a mighty big zap. And now it is dropping. Look at that, it's down to 95 volts at this point. So just having it stay off for a few minutes, if you don't want to discharge it, it will discharge. But you can't really rely on whatever discharge resistor is currently across these caps, because it could be faulty, and then these could hold a charge and really give you a nasty surprise. So I'm pretty convinced that the high voltage side, the high side of this power supply is working fine, and the problem is entirely on the low side. So now I'm going to use the multimeter in continuity mode, and I'm just going to start looking around for things that appear shorted on the low voltage side. Now these two heat sinks here have diodes that take the AC output of the transformer and turn that back into DC. Let's see if either of those are shorted. 1 ohm, that one? Okay, that's potentially suspect. Okay, so this one up here does not appear shorted. It looks like it's open, or you know, it's acting like a diode most likely. And this one over here, 1 ohm. Now we're going to reverse the leads, see if it's the same the other direction. And yes, it is. It's 1 ohm again. So whatever, that's not for sure that this diode is shorted. It could be something else. So we have to start looking on the bottom side to see what else is connected there and where that short might be. So it's the one that's closest to me, and when I flip it over, it is the one furthest from me. So it's this one right here that seems suspect. And let's just double check that. Yep, there we go, 0.5. So that's definitely quite the short. Now there are lots of other components on here that could also be shorted. Now when you have things that are close to transformers, you have to be careful not to see what looks like a short on the multimeter and think that it is a short, because obviously going between two leads on this transformer can also show up as a short, like 0.9. But that's not a short, that is normal behavior here. See, in 0.49 there, these are just the windings of the transformer that can look shorted. So let's try to look closely at it here. Okay, so there's the diode and the heatsink that looks like it's shorted. This is the one leg of the diode, and the other leg is attached to the heatsink, which are these two pins here. Notice here that that pin goes down right there to this connection on the transformer, and then the heatsink goes to this component right here, down to this pin right here on the transformer, and that's exactly the same as the other diode. So the other diode, this one goes to the one leg, and then the heatsink goes to this component right here across over to the same center area as that one. What are those components? Okay, well those are capacitors, and caps can short. So it's possible that, you know, the short actually exists in these caps. Now, if we look at this one, this is the side that's working. Let me make sure I'm still in view. Yes, I am. So we're not seeing anything there, right? It looks okay. Well, it's a short one way. It's not a short, it's like 300 ohms. But the other way, it is fine. And on this side, it's a short both ways. Now 0.55 ohms is what I'm reading on the multimeter right now. And let's just check across the diode. 0.55 as well. Now again, this could be a red herring if we see the short right here, because it looks like the trace also goes up here to whatever this is. And I don't know why that has such a long lead. And that is a 0.45 ohms right there. So that's actually lower resistance than the stuff I was measuring down here, which kind of leads me to believe we're getting closer to the short. Let's look at what that is exactly, that component. Oh, it's an inductor. All right, so that's normal. Inductors will show up as a short. Continuing down the chain, we have something there. Let me just feel for what that is. It's a capacitor electrolytic. Let's see what this reads as, 0.50. And on this electrolytic, I'm going to assume that over here on the right side, that is the positive side, and this is the negative side. And if we follow the trace, it actually goes back to the negative side over here, which we were originally looking at. So that component could be shorted. I'm just gonna draw a line there. That might be shorted. The inductor is fine. That one could be shorted, but I doubt it. It's usually more likely smaller caps is what I've found that can go short. How about this component here? That's not shorted, that's fine. That component looks fine as well. Or the diode itself could be shorted. My hunch, because that's a really chunky diode, let's start with this capacitor right here. Let's pop this out of the board, see if that changes anything. Now on this board, the legs of the capacitor have been bent over, which always makes desoldering it a little more tricky than if they're just straight up and down. Now this is a pretty large electrolytic, and like I said, I don't really find the electrolytics are typically ones to go short, but it is possible. Okay, so there it is, I just popped it out. And let's see if that's changed anything. Nope, still a dead short. So this cap's probably totally fine. And yes, incidentally, on this side here, it was negative. I mean, we don't even need to draw that on there because I know it's a negative rail because it goes over here to this area, which is definitely a negative rail. All right, just realized something right now. The positive side of what we're looking for, the shorted rail, goes over here, and this is a jumper link. Pretty sure that's a jumper link. Yeah, it's a jumper link. So it makes its way over here, and it goes over to this area, and it's going to these transistors right here. And it's these ones right here. And I'm wondering if these are the short. Maybe I shouldn't have even taken this one out. I'm going to put that cap back in, actually, before I forget. All right, the capacitor's back in. I'm going to remove this jumper link that was on here. With the jumper link lifted, theoretically, that short should be gone. I'm checking across the cap that I reinstalled. Yes, it's gone. So definitely the short exists over on this side, over here. And this is definitely the area where the short appears to be, because the jumper link is right there. It was heading over to those transistors. So I'm just going to do some poking around. So we know negative is right here, so I'll just put the probe there. And this is the jumper link I lifted, and it's definitely shorted there. That's not shorted. Let's see about here. That is a dead short right there. That makes its way over to, what are these? A bunch of resistors here. So that's fine. It kind of looks like right here might be the issue. So it goes to the jumper link, it goes across here, goes to this transistor on the middle pin, and then this pin here actually is connected to the minus where I am, but it seems shorted across right there. Now that, again, this might be a red herring because it could be up here somewhere still, but this transistor definitely shows a short across those two pins. Not across that pin right there. Let's check from here to the positive. No, that seems fine. This transistor here, that's okay. That's a capacitor charging. Swap them around. Looks fine. So definitely right there. Let me mark it with the marker. So it could be right there. I think what I'm going to do is just pop out this transistor because that's relatively quick and easy to do. Alrighty, there it is. The transistor is out. We'll test that in a second, but let's just see if that short has gone away. Looks like it has gone away. Yeah, it looks like it went away. It's now acting just like the other one where there's some charging going on one direction and the other way. It looks good. Okay, so I'm gonna grab the tester. Let's test this thing out. I bought a new component tester, which I have right here. It's one of these jobbies. So let's pop this in here. Yeah, 0.3 and 99 ohm. That's a bad component right there. What is this? It's a 2N6394. I gotta go look up what that is exactly. And a quick Google has found that this is an SCR, or a silicon controlled rectifier, 2N6394. What I'm not sure about is what this looks like when you test it. And unfortunately, I don't have any replacement of these parts. So in order to test if this is the only problem on here, I think I'm going to steal one off one of the other Macintosh power supply boards, and then I can order replacements. All right, the one on the left is the one I stole off the other board, and while it looks like a different part number, it is the same thing as, I think it's a 6395, which is a slightly uprated version of the 94 part that was on this board. Well, let's give it a test in the tester. Let's see how this thing sees it. It sees it as a resistor, but I'm not surprised. I don't think this thing can test SCR specifically, but the fact is the bad part here had two of the pins basically shorted, and I think that's the fault. Alrighty, I just reinstalled the part into the board from Tommy with the multimeter here. Let's see. So we got a little bit of a beep, but that's normal as it's charging up the caps. Same there. So I think the short is resolved. And this was where it was shorting across this cap, and it's not anymore. And same thing across this diode here. So see, you get a beep for a little while and then it goes away, which is exactly how it works on this one here too. See? Okay. So I think we're ready to give this thing a test. I'm plugging the CRT back in. I'm going to connect the motherboard back up, and we'll grab the multimeter and check for the 5-volt rail, because I don't know what kind of mucking about has gone on with the pots on this board. So hopefully it doesn't send like 8 volts into the power into this motherboard. That would suck. I mean, maybe I should power it up first with the motherboard disconnected. I think I'm actually going to do that. And let's just see if the short seems like it's cleared. I just don't want to potentially damage this motherboard. All right, so the deflection yoke's connected, high voltage is connected. We're not going to get any high voltage out of the motherboard. It's not possible. The motherboard is required to generate the horizontal sync that allows the horizontal deflection circuit to work, which is what generates the high voltage. So we're not going to get high voltage, but I am on the 5-volt connector here, or the pins on the connector that go to the motherboard. So let's just quickly turn this on, only for a split second. It is on, but the 220-volt step-up transformer is off. Before I do power this up, though, I'm going to wear these safety goggles just in case something flies out of this thing. Okay, here we go. Okay, it sounds like it was running, but it was kind of restarting. So this went up to 3-point-something volts. That might be normal because there's no load on it because the power supply or the motherboard is disconnected. So let's get the motherboard connected and we'll try that again. It didn't sound like it was shorted this time. So that's a good sign. All right, hopefully you can see the multimeter. There it is. Here we go. Whoa, yeah, we are at 6 volts there. Way too high. Now, normally on the back side of the power supply, there's this plastic cover that has an indicator of which control is which. That is not on this power supply. Therefore, the layout of the potentiometer is just slightly different. So I'm not 100% sure which is the right potentiometer for the voltage regulation. So I'm gonna unplug the power supply again and we're gonna turn this on and I'm just gonna turn the one I think it is and see if I can affect the voltage. Okay, so let's see, the power supply is not working properly. It keeps trying to like start and stop. Yeah, that's not doing anything. I need to hook up something to the 5-volt rail, some type of a load, just to kind of get the power supply working properly. Alrighty, I went into my parts bin and I found a light bulb. I think it's like a turn signal or something from a car, or maybe it's a brake signal. It's a dual filament bulb. Either way, I just soldered wires right onto it. It's connected to the 5-volt connector there. Let's turn this on and see if it works. It's having trouble starting, but there it is, 6.9 volts. That's a bit high. So let's see, does this control work? This is not the control for it, I don't think. How about this one? No, neither of those seem to control it, and it's at a 7 volts, a bit high. I'm pretty sure that that's the adjustment there for the voltage, and it doesn't seem to change it at all. And I'm wondering if this Zener diode here that has the arrow pointing to it is somehow bad. You know what, I just realized something. I never reconnected the jumper lead there. I'm gonna unplug the power here. The jumper lead that I disconnected to break the short off the main part of the power supply. So I have a feeling the regulation is just not working right now because that jumper lead is disconnected. Oops. I have a feeling people were probably screaming at their screens saying, hey, no, you didn't reconnect that. I completely forgot. Okay, I have reconnected the jumper link there. It's a little ugly in there, but I did test it with the multimeter and it is connected. The light bulb, let's just move this into frame here. So right there, so you can see it glow. And let's just reconnect the multimeter to the 5-volt rail so I can check for regulation. I can't believe I powered it up with my motherboard connected without the regulation working. Okay, one last double check. Multimeter's connected. That's not shorting. Light bulb is connected. Let's plug this into the step-up transformer. Okay, so it's turning on now, but it's not starting. Okay, I have 2 bulbs on here now, and it does start, not happily, but it starts 5.2 volts, and the potentiometer seems to regulate things now. So I think at this point, it's probably okay to reconnect the power supply. I think that's gonna give it more the current that it expects, so the power supply should be a little bit more happy than it is right now. Okay, here we go. I'm a bit nervous, but let's try it. Oh, still way too high, 5.8 volts. Let's try turning this and I'll turn it back on. 5.1 volts. Let's turn it down a little bit more. 4.86. I also think there's high voltage, by the way, right now. Okay, 5.0 volts there. I feel so bad. I gave this motherboard like 6-point-something volts. Hopefully nothing got destroyed on it. I mean, it booted up. You know, that was the good bong sound. I'm pretty sure it was generating high voltage. I heard what sounded like high voltage coming out of the CRT. There won't be any image, of course, because I don't have the connector on the back of the CRT itself. So without that, the high voltage is present, but you get no image. I'm going to try to rearrange it a little bit to see if I can get the connector on the CRT. I just want to see it actually generating an image. Alrighty, it's precarious, but it is hooked up. Let's see what happens here. Let me just double check. The ground lead is connected to the CRT. High voltage is connected. Motherboard's connected. The multimeter is still visible. And here we go. Let's turn this on. 5.02 volts. And do we have an image? Do we have an image? So far, nothing. Although, again, someone might have been fiddling around with the various potentiometers on here, so it could be that the sub-brightness control or the screen control is turned all the way down, and it's those controls right there. Well, it doesn't appear that there's any image whatsoever. But obviously, sounds like the motherboard is working because we have 5 volts. What I don't know is maybe that 6 volts or 6 point whatever I gave that thing damaged something on the motherboard. So I think what I'm gonna do is I'm gonna put this analog board into the chassis, into a Mac Plus chassis, so I can have everything in there properly, and then I can start probing around on the analog board with everything powered up with a multimeter, just to check to see if I have a video signal and stuff like that. Because right now, we're getting nothing. Alrighty, so the machine is back together for the most part. This is Tommy's power supply in here. And the funny thing is, I plugged this power cord into it and it tripped my breaker, and the whole thing was off actually. So my assumption here is that the Rifa cap that's on here, which I haven't removed, is actually between live and ground, and it is going bad. So I need to get that out of here, and I might as well do it right now while the board is in here and kind of propped up. All right, there it is. That was a bit of a pain to get out of there, I have to say. 0.47 microfarad X cap. Let me plug this back in. No, it just tripped the breaker again. It's really weird too, because the step-up transformer is off right now. So why exactly is this tripping the breaker? I'm wondering if the switch on there is switching the neutral and not the hot. 123 volts between that leg and ground. And what about this side here? Same thing. Weird. Let's turn that on. 123 volts there. 123 volts. And 245 volts between hot and neutral. And with the step-up transformer turned off, hot and neutral, nothing. And we turn it on. And there we go, we get the 245 volts, which is basically about double what my house voltage is. 122 is normal. And I'm just checking that the ground lead that goes into the step-up transformer is also going to the chassis, and it is. It's sort of jumping around, but I think it's around 1 ohm, which is expected. And taking a look between the ground and the chassis, we're at about 7 meg ohm on that pin, and this one about 6 meg ohm. And a quick Google search says that you need to use a 20K ohm to test the GFCIs. That's the ground fault interrupter breakers we have here in the US. So 20K. So this meg ohm that we're reading on here theoretically shouldn't trip the breaker. Also, it's weird because we did all that testing and it wasn't tripping the breaker either, but the difference is now that it's in this chassis. Very strange. All right, so what I'm gonna do is I'm gonna use an isolation transformer, and I'm gonna plug the step up into the isolation transformer, which I think should separate the ground, so it shouldn't be referenced to my house anymore. So let's plug this into the Macintosh here and see if it trips the breaker. It did not trip the breaker. So there we go. I think we're good to go for testing at this point. So just to summarize, it goes from the mains in my house, 120 volts, into the isolation transformer, and then from this, it's plugged into the step-up transformer, and then this is plugged into the Macintosh, which is currently off. Let's turn it on. Okay, nothing happened, and then I turn this switch on here, and that should turn on the Macintosh. There it is. I'm not sure if this is a fault, or this has something to do with the way this step-up transformer works that's causing the breaker to trip. Okay, just like before, there is no video, which you can't see because the camera's not pointing that way, but take my word for it. Okay, so we're not gonna get any activity on the CRT unless we have 12 volts, and that makes the filament glow here. And to be honest, I'm not seeing anything at all. Let's check to see if there is actually high voltage. Oh, you know what? Let's use the Android app. All right, using my app on the phone, I do see that we are getting the correct peak. It's right around 22 kilohertz, which is correct. So horizontal oscillator is running, and I'm assuming we probably have high voltage. Let's get the probe and just make sure. Whoa. The anode just popped off and actually like arced to the CRT. So yeah, there's high voltage, all right. Let's just let that hang down for a second. And I'm gonna check to see here. Yeah, we had high voltage stored in the CRT, so that's just discharging it right now. Why did that cap pop off? Just rudely came right off. All right, it's on there now, it's not falling off, so let's get the probe under there. Let's turn this back on. Yep, about 12 kilovolts, which I recall is the normal amount for the Macintosh for this size screen. 10 to 12, probably normal. We have high voltage, even after that little arcing incident. I think it burned some of that sticker right there. I think the problem is there's no filament here. There's no glow on the filament. Turn that on. Without any filament voltage, which should be about 12 volts, we're getting nothing. Now, I've done videos in the past, let me turn this off actually, about bad solder joints on these boards, especially on the connectors. And that could easily be a bad connection going to here on the CRT from this board. So that's the connector there that goes to the CRT. This is the one that goes to the motherboard, and that's the flyback. And there's also a deflection yoke one somewhere over here. So I'm gonna reflow all of those, and let's see if that improves the situation. Now, incidentally, the CRT circuit runs off 12 volts, and so does the heater. The fact that we have high voltage means that there's 12 volts getting to this part of the board. So it's not like the main power supply is problematic, because you know that could be a problem. They say there's no 12 volts, but we had 12,000 volts, which yeah, that's not going to happen unless you have 12 volts from the power supply getting to the CRT circuit. Okay, I was going to reflow the deflection yoke, but it's like underneath this foam right here, so yeah, that's not easy. I mean, I'm gonna assume that it's okay. If we see any weird deflection issues, once this thing has a picture, I'll try to scrape that away. Alrighty, here we go. Nice loud beep. Let's see if we have a picture. Nope, we don't have anything. All right, I'm turning the cutoff control and adjusting the knob on the front, and there's nothing. Okay, so I'm gonna go back to, I'm gonna first kill the power. I'm gonna go back and we're gonna try to figure out if there's filament, because you should see a glow and there's no glow. So let's take a look here. I'm looking for 12 volts. 52 volts, that might be the cathode. There was 12 volts right there, looking good. And then these ones are probably gonna be like the focus and the screen voltages. So this one's probably very high voltage, 317 volts. And this one here, 225. Okay, so 12 volts is seemingly on that connector there, and yet I'm not seeing any kind of glow on the filament here. All right, and actually I should have just done this. I turned off all the lights and I can see the filament glow. I can actually see it through the little end part here of the CRT. It's inside some cups in there. Wow, you can't even see my hands. It's inside these little cups. Therefore, it's blocked when you look at it this way, but I do see the glow there. If I turn off the computer, it goes away, we turn it back on, and there it is, it comes back. So that tells us there's a problem with the video signal. So next step is I'm gonna break out one of the little oscilloscopes. We're gonna at least make sure that the video signal is getting from the motherboard up to the analog board. I'm gonna use my 100-to-1 probe. It's a little bit safer when you're probing around things that are potentially high voltage there. And of course, using a battery powered scope means that everything is fully isolated. Not to mention the computer's already isolated because I have it on the isolation transformer. And let's start probing around. This is the connector right here that comes from the motherboard. So we'll turn the computer on, turn it on, that's very loud. I'm gonna change this to 2 volts per division. And let's look through here. Okay, that's just a solid voltage. That's a voltage. We appear to have a sync signal of some type right here. Yeah, 22 kilohertz, that's the horizontal sync right there. This pin right here appears to be vertical sync. I think if I zoom out enough, it should be 60 hertz. Yep, 60 hertz, a little over 60 hertz. So that is the vertical. We know that's working. Alrighty, this pin over here is the video signal. That's it right there. And definitely looks like it's working properly. So that's a great sign. That means the motherboard at least is outputting a video signal and it's not damaged. I'm gonna turn off the power. Now what happens is the video signal comes in, it goes through some processing, and there's an entire cathode drive circuit, which then outputs it to the cathode on this connector here to the CRT. So we should be able to see it on the scope. So I'm gonna connect to this pin here, which, yeah, I think right there, I think that's the video signal right there on that pin. Yeah, that's almost likely the video signal. So with the cathode, anytime it goes near ground, you're gonna have white or a visible picture. All right, it's been a little bit of time and I've had some time to think about the problem here with this machine. Let's take a look at these schematics that I found online for the analog board in the original Macintoshes. Now, we already know this is the international version, so it's going to differ slightly, but I think this section right here, which is dealing with the various voltages that go to the CRT, is basically identical on this board. Let's go over some of the fundamentals of how a CRT works before we get back to the schematics. This is a diagram I found online. It's not going to be exactly the same as the monochrome CRT that's in this computer, but I think it's going to be close enough. So the first thing that's required for generating an image on a CRT is the cathode, and it's right here, and there it is. I guess it's this little squiggly line, or maybe it's this box here around it. Either way, it's the cathode drive circuitry that actually sends the image that's going to be displayed on the screen to the cathode. Basically, as it gets closer to 0 volts, the intensity of the electron beam will increase, which will light up a spot on the screen. As I mentioned earlier, for the cathode to work and have actual emissions of electrons, it needs to be warmed up, and that's the heater or the filament that does that. Now, I did check, and there is 12 volts on the heater on the CRT, so we know that's good, and I'm seeing a little bit of a glow. I just didn't quite see it at first until I turned off the lights. So we know the cathode is working because we saw the signal on the oscilloscope of what the Macintosh is trying to display, and I know the heater is working. So those two components are good. The next thing that's essential for generating an image is the high voltage, the 12 to 15,000 volts. We know that's working properly. What that does is it charges the front of the screen with that voltage, and that basically pulls the electrons or accelerates them towards the phosphor, and when they hit the front, they actually glow. We know that that's working because, well, earlier I had the little arc and, we tested it with the meter, so that is all good. Next up, let's focus on these areas right here. These are the different grids that are used to control the flow of the electrons to the front of the CRT. I think on this particular CRT, there are 3 grids or potentially 4 grids. So G1, G2, G3, and G4. I'm not sure what the actual physical construction of a grid inside a CRT looks like, but maybe it's like a mesh where it can actually charge it up to different voltages, or perhaps it's actually like a metal thing that goes around, the electron beam flows through it. Either way, those grids are used to control the speed and the brightness and other parameters of the electron beam. On these types of CRT, grid number 4, the one that's closest to the front of the screen, is used for focusing. And when we go back to the schematics here, we can see there's the focus control pot, this R54. And that goes to this pin on the CRT. That's going to go to G4, grid 4, and the focus range is from 0 to 500 volts. Changing the voltage on that particular grid is what allows you to focus in the CRT. And with a lot of monochrome CRTs, actually just having the focus grid G4 at ground is the appropriate value, but I'm not sure what it is on this CRT. I think I measured it and it was like 300 volts or something like that. The next relevant grid in a monochrome CRT like this is G2, also known as the screen grid. And when you look at the flyback transformer and there's a control labeled screen, that is almost always connected to G2. And that controls the overall intensity of the image, or the black level of the image. As you turn that up, you will see the black areas of the screen kind of lighten up and you'll actually see the scan lines. On this particular schematic, it is R53 labeled brightness, and the voltage range on that one is 150 volts to 750 volts. Now, I did measure the pins on the back of the CRT, and I was seeing a pretty high voltage there for the screen control, and when I adjusted the potentiometer on the analog board here, it actually was changing. So I know that that particular circuit is working properly, and we should have an image. If that is turned too low, and the grid 2 voltage is inappropriate, then you could just also have a completely black image. But I'm positive that that control is working as well. And the last one, well, this is a terrible diagram again, but it is G1. And G1 is going to be the first grid right after the anode. So I suppose it's this control grid right here. Either way, that is what is actually connected to the brightness knob on the front of this machine. Well, when this board pokes through the hole there, that is G1. And it is this part of the circuit right here with this contrast knob, and the voltage range was -25 to -70 volts. Now what this schematic doesn't say, and I actually don't know, is G1's voltage obviously has this range between -25 and -70. I measured it around -15 volts. So it seems like it's out of spec based on what the schematic says here. Now what I don't know, because I'm not an expert on how CRTs work, is does the image get brighter the more negative the voltage is, like the closer it is to 70, or does it get dimmer that direction? It seems to be stuck at -15 volts, and adjusting the control on the front of the machine doesn't do anything. Either way, I'm not seeing the proper range of voltage on the G1 pin on the CRT, and the contrast knob doesn't appear to have any effect. Moving it back and forth does not change it. So I'm going to say that there's going to be something wrong with that part of the circuit, and that is where I should put my attention. Now I think the most likely candidate for a problem is probably the potentiometer, because this thing was shipped to me and this thing's like banging around and stuff, so there's a good chance that this might be damaged. I do have another working board here so we can test the potentiometer on there. So let's bust out the multimeter and let's see what we see. Okay, I'm on the 2 outside pins and we're at about 495 kilo ohms, and if I turn the knob, it absolutely is changing. Looks like at the lowest end we have 1.6 ohms, and according to the schematic, I think this part should be a 1 meg ohm part. And yeah, we're at 0.9, oh, I'm having bad connection here. So yeah, 900K, close enough. So that's how it should work. Let's see how it's working on this one here. We're at 2 meg ohm, 2.1, and it's going up. So clearly something is up. Let's prop this up a little bit. There we go, so it's not resting on the knob. So I'm going to turn this all the way to one side. Let's see what we see now. So it was basically turned all the way one way. I'm going to turn it all the way the other way. 7 meg ohm. Okay, we'll turn it back the other way. 6.7 meg ohm. Okay, pretty much confirms that part is bad. All right, let's see here. So, oh, it's yeah, it's kind of beat up a little bit. Oh, it's cracked. All right, hopefully this is showing what I'm seeing, but this entire part right here, this leg, is no longer connected to the variable resistor here. I think what I'm going to try to do is like prise this apart, because it's sort of all held together with these metal clips. So I'm going to see if I can get this apart. Well, and there it is. And then, yeah, unfortunately, there's a crack right in the PCB there that sort of builds the body of this thing. This is the underside. There's like a contact that wipes on there. Plus there is this little thing here, which I guess is the, I don't know, what is it, carbon track or something that kind of sits like that. And unfortunately, this little carbon track thing, it's not supposed to be loose like this. It's supposed to actually be connected to the 2 pins that go down to the bottom. So there is no fixing this little thing. This thing is totally dead. So I think what I'm going to do is I'm going to measure what this is, probably turned in the middle somewhere. I'll figure out what the middle is, and then I'll just install a fixed resistor into here that is close to what this is, and we'll have to rely on that internal control over here to see if we can get an image on the screen. And it seems like 360K or so was the middle setting on that other board, and I have a 330K resistor here. So I'm just gonna solder that on between the 2 outside pins on here. Let's see what happens. Okay, so the resistor is in place. Board is mounted back in here. I have it hooked up to the step up transformer and the isolation transformer. It's currently off. This is set to the on position. Incidentally, I took this wire off. It actually ended up breaking off, and I don't even know if this is needed, so we're just gonna leave that off. It's less dangerous floating around that way. There's a mirror so we can see if the CRT lights up. What I do need is some way to adjust the, I think, brightness control. It's gonna be one of these, focus and brightness. I don't remember which is which. So we'll get ready for adjusting those. And I think we're good to go. So here we go. Okay, it's on. Remember, resistor is in, but the entire potentiometer has been removed from the board. There's nothing showing up on there yet that I can see. So the brightness control is the top one here. Oh, it's actually booting. I forgot I had a disk in this computer. Oh, alrighty. We have an image. Well, it's not a great image. Let's move the camera so you can see. So there it is. We're actually getting raster now. I never got that before. Good sign. What we're not seeing is actually an image from the motherboard. Let's see if we can fix these geometry problems. I think this control here should be the height. Yeah, it is. Okay, so height control is working as it should. So we have a raster, but we have no image. So it's definitely time for the oscilloscope again, because I want to see if we're actually seeing the video signal again on here for the cathode drive. Now remember, I'm using this battery-powered scope because it's completely isolated from any mains earth. I mean, the computer is isolated because of the isolation transformer, but just to be extra safe, and I'm using a 100x probe as well. All right, so there's the video signal coming from the motherboard into the analog board, and I'm at 2 volts per division. So we're looking at the desktop there because this computer is actually booted up. I'm going to change this to 100 volts per division, and we're going to take a look at these pins that are going to the CRT. So this one appears to be the actual signal for the cathode. Let's change the division. So there we are at 100 or 10 volts per division, and that is going to be the actual desktop image. So we know that's getting through to the CRT, and I just noticed that we have an image on the computer, and I wasn't looking in the mirror, and I bet you people were like, hey, there's an image. Something is the matter here, because I noticed there, you see that it kind of dimmed out? Let's bump this. So we obviously have some bad connections going on, because look at that. When I bump this, it gets brighter. So we have some kind of loose connection on here. Which pin was it? Certainly when I touched this one here, when I push on that cathode drive, it gets brighter. This could have been a problem the whole time with this, with a bad connection as well. I mean, there's multiple issues going on with this board, but hey, it's looking good. So I'm just gonna turn the power off to it. And I thought I reflowed these connections here. I mean, they look shiny. Clearly I didn't, or I did a bad job. Actually, you know, it could be the issue as well, is the connector on the other side may be heavily oxidized. So I may just need to actually do some deoxit on there. Let's turn the power back on. But definitely we had an image and it looked correct. So I'm gonna say that, yeah, this thing is fixed. I mean, other than this busted knob here, do we still have nothing? Okay, we still have a bad problem there. You see that? Let me just turn the power off again. I think deoxit is in the future of this thing. Right here, this is the connector. The power is off, just in case. I will pull the power cord there. But I have the little deoxit thing here, so we'll just drip some in there. And I'm gonna put some on the pins as well, okay? Alrighty, here we go. Let's try again. I'm gonna turn the power on. Hopefully that did the fix. There it is, look at that. It is repaired. Isn't that awesome? Let's see, what do we need to adjust? The height, it's a bit too tall. We'll lower the height down a little bit. The width is also out of spec. Oh, it's quite bright as well. So turn that back down again. This particular computer has a really nice, strong CRT. I mean, I'm glad to see that this machine survived after I gave it like 6.5 volts or 6.7 volts or whatever on the motherboard. Clearly, it suffered no catastrophic damage from that quick overvoltage. So there we have it. This analog board is freaking working and it looks perfect. There's, I would say, no other issues with it, other than, of course, the 1 meg pot that broke on it needs to be replaced so you can actually adjust the brightness on it, because right now there's just a hole there that does nothing. But ultimately, that resistor fix does do the trick, and if you have a particular machine that has this problem, install that 330K ohm resistor in there, and then you just have to adjust the control on the side of the CRT or the side of the analog board to get it to a good position that's not too bright, not too dim, looks good on your system, and then, well, there you go, you're just not gonna be able to adjust it. If anyone happens to know if these 1 meg ohm potentiometers are being sold and ones that work, you know, in this Mac that are compatible with it, put a link in the description below or put a link in the comment section, and I'll try to pin that for anyone in the future who might have this same exact issue. But just keep in mind, if you're shipping one of these boards around, be very careful that you don't put undue stress on the potentiometer, because once that breaks, well, you're not gonna get any kind of working image. And of course, the first issue we had with this board that prevented the whole machine from working was this SCR that had gone short. I still don't fully know how to test these things in my tester. I talked to Frank IZ8DWF and he said that, yeah, testing these is not super easy, but generally if you see any two pins that are shorted, that is gonna be a problem. And that is exactly how this one looked. So I stole the one out of another board and there we go, that works. Luckily this is a very common part, so it'll be easy to buy replacements of these to get this thing working again. And then the final problem we had was some dodgy connections going to the CRT, and looks like we still have a problem with bad connections on this thing. It's not crashing the computer, but it's getting brighter and dimmer. So some more deoxit, some more cleaning of those pins, probably will get that fixed right up. I want to remind everyone again, of course, if you're working on something like this that has mains voltages in there, plus all the high voltages that are generated for the CRT, this thing can be lethal. So make sure you work safely. I've been using this isolation transformer that was sent in by a viewer, so thank you very much for that. That just adds the extra safety, but that's not to say that I still can't get shocked by this thing. So you have to be very careful and only work on this if you know what you're doing. I do want to point out one final thing with this repair. I hope everyone noticed that one thing that was not wrong with this was bad capacitors. I didn't touch any of the capacitors. Well, I did take one out because I wasn't sure about it, but put it right back in the board. So all the original caps are in here. None of those need to be changed. All the faults that existed were somewhere else. And in my experience, especially with these older Macintoshes, because these things are so reliable, that is almost always the case. Anyhow, I hope you enjoyed this video. If you did, thumbs up. If you didn't, you know what to do. Comment down below, subscribe, all the usual YouTube junk. Thanks to my patrons. Their names are scrolling up the side of the screen. Thanks, Tommy, for sending this thing in. Check out his channel. I'll put a link in the description below to his channel. He's in Norway and has a cool Norwegian accent. Plus, he has a second channel with some awesome footage of the beautiful nature and scenery up in Norway. I really recommend you check it out. That's gonna be that. Stay healthy, stay safe, and I'll see you next time. Bye-bye.